I'm Dr. Musil, and in this video we'll be talking about categorical operations that you can apply to standard form claims and arrive at different claims, some of which, as we'll see, are going to be equivalent to the original claim and some that won't be. So again, these are known as categorical operations, and for what it's worth, I think this is one of the trickiest aspects of Chapter 8. It's one of those things, again, for better or worse, you're just going to have to memorize these three basic operations, sort of the process by which you complete them, commit them to memory, and then I think once you have them memorized, then they're pretty easy to apply to the various standard form claims that you encounter. So a couple things right off the bat. We have to define a couple important concepts here. The first is the idea of logical equivalency. So two things are logically equivalent, or two statements are logically equivalent if and only if they'll have the same truth value at all times. So it's not possible for the first claim to be true and the second claim to be false, right? They will always have the same truth value. So if that is the case, then they are said to be logically equivalent. If it's possible for them to have different truth values, then they're not logically equivalent. Okay. Then we have the notion of complementary terms. Two terms are complementary if and only if they identify every possible member, right? So nothing's excluded when you include both concepts or both terms. So for example, dogs and non-dogs, right? There's nothing left. Those two cover every possible case or instance or member of a category, a possible class or category. Okay, so again, two terms are complementary if they identify all possible members. So with those two basic concepts, then we can go ahead and turn our attention to these three categorical operations that we can perform on standard form claims. So the first one we have, and I think this is the simplest one, is what's known as conversion, right? So you simply swap the subject and the predicate, right? So let's say you started with an A form claim, all cats are animals. If you were to convert that, right, the result would be all animals are cats. Okay, so again, to convert a standard form categorical claim, all you have to do is switch the subject and predicate, okay, which we've done here. Now, two of the standard form claims will always be logically equivalent to their converses. So after you apply the operation of conversion, what you get will be equivalent to what you started with, right? And those will be the E form claims and I form claims. What we started with here, though, was an A claim. And this will not be equivalent to its converse, right? As we see here, right? Just because it's true that all cats are animals, that's not going to mean that it's true that all animals are cats, right? So again, only E and I standard form claims are equivalent, logically equivalent to their converses. Let's go to an E claim though and see how that will be equivalent. So if we have no cats are dogs, and what's the converse of that? You just switch positions, right? So you'd have no dogs are cats. Okay? Those are logically equivalent. Anytime this first one is true, this is going to be true. And anytime this is false, this has to be false. Okay? No cats are dogs. If that's true, then no dogs are cats. That's going to be true. So that's the idea of conversion. The second, I think the second and the third one, again, for what it's worth, are a little more tricky because there's a couple things going on. So we have the operation of obversion. Okay, so the first thing we do is we go horizontally across the square of opposition. So again, we're building on something we just talked about in the last video, this idea of the square of opposition. So the A and the E, right, are you would go across the square in that direction. So if you started with an A claim, you would go to an E claim and vice versa. Or if you started with an I claim, you would then go to an O claim or vice versa. So you go horizontally across the square of opposition, and you substitute the predicate, the second term listed, with its complementary term. So let's go ahead and do that. Let's go with an A claim again. All cats are animals. Okay, what would the obverse of that be? We go across the square of opposition. So that's going to turn into no, right? We're starting with an A, so we want to get it over to the E side. No cats. And the second thing we do is use the complementary term for the predicate. So no cats are non-animals. Right? We started with animals. What's the complementary term of animals? Non-animals. Okay, and usually you can just stick the non in front of whatever term we're talking about, and that'll turn it into its complementary term. So what standard form claims are equivalent to their obverses? All of them. So no matter whether you start with an A, an E, an I, or an O claim, and you perform the operation of obversion on it, what you get is going to be equivalent to what you started with. Right? So all cats are animals. If that's true, then it's true that no cats are non-animals. That's always going to be true. Right? So again, it doesn't matter which one you start with. The obverse that you get after you perform that operation of obversion is always going to be logically equivalent to what you started with. And the final operation we have is what's known as contraposition. Okay, so here you swap the subject and predicate and use the complementary terms for both. So you're doing exactly what you did in conversion, but then you're taking the additional step of substituting the complementary terms for both of them. So let's start with an A claim. Again, all cats are animals. I think this is the most confusing one just because of how many complementary terms you have involved, and it always sounds a lot weirder to me to be saying non-something numerous times. So this, right, the contraposition of this would result with all non-animals are non-cats. So what are the two things we did? Again, we switched the positions of the subject and predicate, and we used the complementary term for both. Okay, and to me, again, I think that's a little awkward, right? All non-animals are non-cats, but that is going to be equivalent to the thing we started with, right? So which standard form claims are equivalent to their contrapositives? A and O, and we started with an A, so whatever we end up with after performing that operation, it's going to be equivalent to what we started with. Now, if we did an E or an I, then and performed that operation on it, what we yielded would not be equivalent to what we started with. But anytime you do an A or an O claim, what you get is going to be logically equivalent to what you started with. Okay. So hopefully those are starting to make a little bit more sense. Again, practice, 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 and hopefully they'll become more ingrained and, again, kind of like second nature as you go through the quizzes and through the homework exercises. Let's go ahead and do a few examples here. So let's convert this O claim, some Patriots fans are not philosophers. So we want to convert or apply conversion. Right, so what happens when we convert that? All we do is switch the subject and the predicate, right? So some philosophers are not Patriots fans. And is that logically equivalent? No, it's not, right? Remember, only E and I claims are going to be equivalent to their converses, not an O claim, which is what we have here. So just because some Patriots fans are not philosophers doesn't mean that some philosophers are not Patriots fans. Now, it's probably the case, but that doesn't have to necessarily be true. Let's do another example of conversion. So let's start with an E claim. No fans of mine are fans of yours. Let's convert that. Okay, convert that. Well, what would that look like? Well, you just, again, switch the spots of the subject and the predicate. So no fans of yours are fans of mine. And that is logically equivalent to the first thing, right? If it's true that no fans of mine are fans of yours, then it's going to also be true that no fans of yours are fans of mine. Right? So again, every E and I claim will always be logically equivalent to its convert. Let's do an example of obversion here. So let's start with an A claim. All princesses are people who live in castles. So we want to obvert that, or perform the operation of obversion on that. What results? Again, first thing we have to do is go across the square of opposition. So if we started with an A claim, we know we're going to get an E claim, right? That's the first part we have to do, right? So it's going to be no princesses are, and now we need to substitute the predicate with its complementary term, right? So we started with people who live in castles. Now we want the complementary term, which would be people who don't live in castles. Okay, and that is logically equivalent, right? So if it's true that all princesses are people who live in castles, it's also going to be true that no princesses are people who don't live in castles. Okay, so, and you'll recall with obversion, it doesn't matter what standard form claim we start with, it's always going to be equivalent to its obvert, whatever results after we perform the operation of obversion. Right. Let's do another sample of obversion here. Let's start with an I claim. Some fruits are sour tasting foods. And again, we want to obvert this. So what results? We have to go across the square of opposition. So we're going to have an O claim, right? So it'll be some fruits are not, and this is where it gets, I think, sort of sounds convoluted and awkward, right? Are not, and then we need the complementary term of this. So I guess I'd say something like non-sour tasting foods. So some fruits are sour tasting foods. Perform the operation of obversion on that. You get some fruits are not non-sour tasting foods. Okay? And that is logically equivalent to what we started with, this basic I standard form claim. Because again, it doesn't matter what we start with, whether it's A, E, or an I claim, or O claim, right? It'll always be equivalent to its obverse. And the last operation, contraposition. So let's start with an A claim here. All hockey fans are awesome people. And we want to perform the contrapositive. We want to contrapose those. All right, so let's perform the operation of contraposition. Right, what results? Okay, well, again, we're going to do the same thing we did in conversion, right? We're going to switch the subject and the predicate, but then this time we're going to use the complementary terms for both of them, right? So we'll have all non-awesome people are non-hockey fans. Okay. And remember, anytime we start with an A or an O claim and perform the operation of contraposition on it, it's what we yield is going to be logically equivalent to what we started with, right? So if it's true that all hockey fans are awesome people, it's going to also be true that all non-awesome people are non-hockey fans. Okay. And one last example. Let's start with an I claim. Some dogs are ferocious creatures. Perform the operation of contraposition on that. And what we get are some non-ferocious creatures are non-dogs. Okay. So we started with an I claim, and we know that only A and O claims are going to be logically equivalent to their contrapositive. Right, so we start with an I, it's not going to be logically equivalent to this. So just because it's true that some dogs are ferocious creatures doesn't mean it's true that some non-ferocious creatures are non-dogs. Again, I just think that sounds very awkward, but that's where if you just remember these, memorize, if you will, these basic sort of notions, right? When are they equivalent, right? What do you have to start with that's logically equivalent to results after the operation. If you can remember only A and O are equivalent to their contrapositives, then you'll know that if you start with an I, it's not going to be equivalent, regardless of how funky it sounds, to its contrapositive. So that is the notion of categorical operations there. We went through the three basic operations that we cover in the textbook. Hopefully you feel a little bit more comfortable using these now, and hopefully this video was helpful.